which is 1 over 10 times 9 times 8 times dot times 1. Is that less than or equal to 1 over 10 times 9, just keeping the first two terms?
Yes.
Sure, I'm throwing out a whole bunch of the bottom, right? So the bottom is getting smaller, so the whole thing is getting bigger. So that's 1 over n squared minus n. That one we could prove converged with one of our tests, I bet. Because that looks a lot like 1 over n squared. Maybe the limit comparison test was 1 over n squared. I'm giving you a different way to think about it. I'm just giving you a different idea. I think I could push this one through. I don't want to right now. But I think you could push this one through. And so, if that's true, then I could get that the sum of 1 over n factorial is less than or equal to the sum of 1 over n squared minus n. So now all I've got to worry about is this one, which I suspect if I did the limit comparison test with 1 over n squared, might work. I'll play with it. I don't want to wing one here that might just waste our time. I'll think about it and see if we can make it work. Okay, 290.4. That's another way. So anyway, this one's still, I mean, I think he's got a nice argument that shows you a way to do it. You definitely get 3 out of 4 on a test because the only thing he hasn't done is prove that last statement. So that's a nice approach to it. Here's a way I think you can make it work and make it all the way to the end. So who's next? 290. Gerardo, what, you didn't put a number up there.
296.
Okay, yours is a high number. So 290. 1.2. Chris?
The series 2n plus 1 to the 1 over n. So I used the integral test and integrated 2x plus 1 to the 1 over x. And got it down to 2n squared plus 1 over 2n plus 2 minus 9 over 4, which this goes down to infinity, so it equals infinity, so it diverges by the integral test.
Oh, I think we're in trouble.
Okay.
I don't believe you're integral, because taking the derivative of things that are x to the power x is nasty, 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 and I don't believe the derivative of what you've got would be that integral. I do actually think you're right. I do think it diverges, though. Right. If you've got something like f of x equals, say, x to the 1 over x, and you want to take the derivative of that, we worked really hard to take the derivative of things like that last semester. You have to take the natural log of both sides. So then ln of f of x equals 1 over x ln of x. So the derivative is f prime of x over f of x equals the derivative of the first, which is negative 1 over x squared times the second, plus the first times the derivative of the second. So then f prime of x is this nasty all of f of x times all of that. So now if we were taking the derivative of what you got here, we'd have to do the product rule, derivative of this times this, plus this times the derivative of this, with me? Or derivative of this times this, plus this times the derivative of this. If we took the derivative of this, we'd have to do something horrid like that, and it wouldn't come out to be something that nice. So, darn. Okay, so this one's still open.
So if we started with the end-term test, how would we do the natural log on both sides?
You would have to, that's right. That problem is there to see if you remembered the hardest stuff from calculus. You guys, Chelsea. Pardon?
I was hoping that you would show it.
Oh, you hoping that I'd show you how to do it. But you sound like you know how to do it.
I just forgot how to natural log. But
Just like I just did here. If you're trying to figure out, I'll get you started. So Chelsea's giving you a hint here. What you want to do is take the limit as n goes to infinity of 2n plus 1 to the 1 over n. So if you saw this one on the test, right, and you look at it and you think, well, looks pretty nasty. One of the questions you could ask is, do I think the limit as n goes to infinity of this thing is 0? Because if it's not, you're done, right? It diverges by the nth term test. Well, just be lazy. Just plug 100 in there and see if it looks like it's going towards 0. Plug 1,000 in there on your calculator. See if it looks like it's going towards 0, right? If it doesn't, then you try to prove that it doesn't. And she's asking, how do you remember? She's saying she. So if you want to compute this limit, let's call it L. Then what you do is you take the natural log of both sides. Now you can actually swap the limit and the natural log. Now you can put that 1 over n out front, right? Now, you're going to have to use L'Hopital's rule or something. Equals, you're finally going to get a number, but now is that number what this limit is? No, that number is what the natural log of that limit is, right? So you're going to end up with natural log of L is that number, and so L is what? E to that number. Okay, there we go. So somebody can finish that one, maybe Chris next time. But now you know how to do it. The answer is this isn't going to be 0, and since it's not going to be 0, it's going to diverge. But the way I would look at this problem when you're looking at it on the test, the first thing you'd ask yourself, the first thing you always ask yourself is the nth term test. And since you can't look at the function and tell, just plug a big number in and guess whether you think it's going to 0 or not. Because if it's not going to 0, you're done. Okay. All right, who's up? 290.
Would you run the integral test on that, Dr. Major? Or would you
No, I can't integrate it. I would not do the integral test because I can't integrate it. I can't tell you that I know that it can't be integrated either, but I don't know how to integrate it. I've never spent any time trying to integrate. What do they call these functions? Darn. When they've got an x in the base and an x in an exponent, there's a name for them. I can't think of it, but I don't know. Okay, who's up? 290. 1, 4. Check.